Hi everybody, Mr. Hudson here. What we're going to do is you will be taking some notes over section 6.4 out of your books. You don't have to have your books open, just have your notebooks open, because what you will do is take notes based on what I do here. If you have any questions, feel free to ask and I'll answer them as best as I can. The title of the section is 6.4 Properties of Special Parallelograms, and we're going to talk about different types of parallelograms, starting off with the rectangle. First of all, we better decide what exactly a rectangle is. What a rectangle is it is a quadrilateral with 4 right angles. Okay, so that's what we're talking about when we're talking about rectangles. It's a quadrilateral with 4 right angles. There are some properties of rectangles, the first of which states that if a quadrilateral is a rectangle, then it is definitely a parallelogram. This makes sense because opposite angles would be congruent, obviously, therefore this is a parallelogram. Also, one of the unique properties about about a rectangle is the fact that the diagonals are congruent. That is not necessarily true about all parallelograms. However, that is true about all rectangles. So we can say that all rectangles, their diagonals are congruent. So here AC will be congruent to BD. Also, we can note down here the fact that since a rectangle is a parallelogram, then all of those properties we've talked about in the last couple of sections also are true. So let's look at some things here. So here's an example. It says a woodworker constructs a rectangular picture. So we've got a rectangle. So the JK is 50 centimeters and JL is 86 centimeters. We are to find HM. Well, if we're to find HM, we know that JL is 86 centimeters, meaning KM, since it's a rectangle, is also 86 centimeters. Therefore, HM would be half of that. That would be 43 centimeters. Down here, we've got a rectangular gate that has diagonal braces. So those are JG and HK. We are to find the measures of HJ and HK. Well, in order to find HJ, that will be the measure of this side. We know that the measure of this side is 30.8. And we are also to find HK. Well, here's the thing. If LJ, or JL, is 30.8, that means this entire segment is 61.6. That's twice 30.8. So the measure of HK would equal 61.6 inches. For HJ, well, if you look, GK is 48 inches, therefore HJ would also be 48 inches. Questions? Okay. Now here's some more properties. First of all, this is a rhombus now that we're talking about, and what a rhombus is a quadrilateral with 4 congruent sides. And my writing's not the best here, but this is a W here. This just means with 4 congruent sides. That is a rhombus. So we have some properties down here. If a quadrilateral is a rhombus, then it is a parallelogram. Also, if it is a rhombus, then the diagonals are actually perpendicular. So with this drawing right here, this is a rhombus because all 4 sides are congruent. We can say that BD is perpendicular to AC, which is what this says right here. Also, if you have a rhombus, another characteristic is the fact that each diagonal bisects the opposite angles. And we've talked about this a little bit before. It almost looks like with all parallelograms, the diagonals bisect each other's angles. However, that's not necessarily the case. With the rhombus, that is the case. These diagonals bisect these angles, these opposite angles. So angle 3 is congruent to angle 4, angle 8 is congruent to angle 7, angle 1 is congruent to angle 2, 5 is congruent to 6, and so on. Okay, now, a rhombus is also a parallelogram, so all of these properties that we've been talking about with these parallelograms do carry over to a rhombus. So if we look at this given information, let's take a look at this. We're to find TV, which is the measure of each side. Now, each side here, since this is a rhombus, each side is the same. So we know that 3b plus 4 would equal 13b minus 9. I'm going to solve that by subtracting that 3b from both sides. I get 10b here. I'm going to add that 9 to both sides to get 13. Therefore, b I would call 1.3. So to find the measure of TV, that has the same measure as xt, so I could just use that 3b plus 4 and take 3 times 1.3 and add 4 to that. This will be 3.9 plus 4, which is, that's right, 7.9. So that would be TV. For the measure of VTZ, well, what we know is a couple things here. First of all, this angle right in here, diagonals are perpendicular. So that 14A, I'm going to use a different color here if you don't mind. The 14A plus 20 is equal to a 90-degree angle. Again, the diagonals are perpendicular with a rhombus. So I would subtract here, get 14A equals 70, so A is 5. To find the measure of VTZ, that would equal the same measure as XTZ. So I would plug that 5 into that expression for A, so 5 times 5 minus 5, and that would give me 25 minus 5, which is 20 degrees. That would be the measure of angle VTZ. Last type of parallelogram is going to be a square, and a square is basically a rectangle with 4 congruent sides. That's what a square is. It is a rectangle, so it has all 4 right angles, but also it has 4 congruent sides. It's almost like it's a combination of a rhombus and a rectangle. So here what we are to do is show that the diagonals of the square are congruent, perpendicular bisectors of each other. Now notice that it says the diagonals here. So we're going to focus on the diagonals. The diagonals are FH and EG. Now there's actually a lot going on here. We're to prove that these two sides are congruent. That means the measures of their sides are congruent. What I need to use in that case, and I'm just going to point to this, is the distance formula to prove that those two sides are congruent. I then want to see, are they perpendicular? And with the perpendicular, if you recall, that means we use opposite reciprocal slopes. Now in order to save time, I'm actually not going to work this out, I'm just going to kind of talk through this. So we would have to find the distance of each of these coordinates, or I'm sorry, of each of these two segments, FH and EG, by using the distance formula. I would have to use the slope formula to show that those slopes are opposite reciprocals. And then bisectors means that we're meeting at the midpoints. So I also need the midpoint, the midpoint formula. So as I said before, there's a lot going on here, but it is a review of a lot of these formulas that we have done in the past. So for each of these segments, what you would have to do is find the distance, find the slope, and find the midpoint to see if they match up with each other. And you will find that they should, or will.